So it's pretty unbelievable that I am starting this off with you. We are going to be teaching sine and cosine. You ready? You sure you're ready? So first of all, take out some paper. You need to take some notes. Seriously, you got to take notes. You're going to need to remember this stuff. All right, we're going on to graphing sine. First of all, do you remember that sine is the y? If this point right here is at 0 degrees, this one's pi over 2, this one's pi, this one's 3 pi over 2. Remember me telling you that circle trig would come back? Oh, it's back. And here's 2 pi. If you went all the way around, you're at 2 pi, right? Okay, then how about this spot on the unit circle? This spot right here, wouldn't that be 1 comma 0? Okay, and then wouldn't this spot right here be 0 comma 1? And this spot, negative 1, 0. And this spot, 0, negative 1. All right, so if we're talking about the y values, because we're doing sine, right, and sine is the y's, then this is the y. I'm trying to highlight it. This is the y, this is the y, and this is the y. Boy, that green highlighter is not the best, is it? Anyway, we're going to be graphing this based on those values. So at 0 degrees, it was 0. Do you see how I got 0 goes with 0? It's because at 0 degrees right here, the y value was 0. All right, how about at pi over 2? At pi over 2, that's right here. At pi over 2, the y value is 1. So then right here, we'd have a 1. And then it gently rises. You've seen sine as a wave before, haven't you? At least I hope you've seen a wave being graphed before. All right, this pi, that's this one, pi, so that's the y value, which is 0 again. So it goes back down to 0. And then it keeps going just like that, negative 1, and then back to 0. You need to memorize this graph, like all the parts of it. How high it goes, how low it goes. That's also called the range. So the range of this thing is from negative 1 to 1. Sine's domain is, well, does it stop really? Does it only go from 0 to 2 pi? No, it keeps going forever. This is a wave that would just keep going in both directions. And so its domain is all reals. We could say negative infinity to positive infinity. Okay, so this base graph of sine is very similar to the one for cosine. Remember that we started with 0 and then pi over 2, which I'm going to call 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2 were the key spots. All right, let's go look at that same idea for cosine. Same spots, right? And now if we want cosines dots, it always starts, instead of starting at 0, starts at 1. How do I know that? Because at 0, this is like the degrees, or in this case, the radians, the angle that's going here, that's the x-axis, right? At 0, it is, this time, the cosine is the x value, and therefore it's 1. And if I go to the next one, it's going to be 0, and the next one, it's going to be negative 1, and back to 0, and then back to 1. And so here we go. This one is pi over 2 goes with 0. This one was pi, and it goes with negative 1. That's down here. And then, oh, I missed. I should go lower. Down here. And then at 3 pi over 2, that's this spot. The cosine is the x value, which is 0, so back to here. And then at 2 pi, that's back to this spot. The x value is 1. The x value is pi over 2, 2 pi, and the y value is 1. All right, so there. Ooh, had a hard time spitting that one out. I like to think of it as 4 parts. That's the first part, that's the second part. Here's the third part, and then here's the fourth part. This is just another wave. If I continued, it would look just like sine. Okay, just goes up and down and up and down. All right, and that therefore has a domain of all reals also. And the range still is from negative 1 to positive 1. So its domain and range are the same as it was with sine. So at this point, I'm hoping that you can graph sine and cosine. So I'm going to give you a moment. You do your best here. Try to make sine and cosine. I'm going to give you the starters. This one was pi over 2. Remember, we count by those. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. I'm going to be nice, and I'm not going to mark that wrong for not reducing. It'd be nice if you noticed that those cancel, and therefore that's pi. And it'd be nice if you knew that this one was 2 pi. Probably kind of important because it's also known as the period of this function. You'll learn more about that in a minute. All right, so let's see if you can graph this, and I'm going to clean it up a little bit. Okay, let's see. For sine, did you start at 0, and then did you go up to 1 and down to -1? Okay, so this goes up to 1 first. That's the first of 4 parts. Here's the second part, goes back down to 0. Here's the third part, goes down to -1, and then the fourth part comes back to where it started. All right, now if they asked you what's the period of sine, the period is how long it takes to accomplish a complete cycle, and that would be 2 pi. So the period of this thing is 2 pi. If they asked you for the amplitude is how high it goes, okay, from the midline up. That's called the amplitude. All right, let's see if you can do cosine. I'm going to pause for a second and give you a moment. Give it a try. Okay, so I'm partway done. I got the axes labeled now, and remember to think of it as like 4 parts. There we go. Started at 1, ends at 1. That's a complete cycle, therefore its period is 2 pi. So that's the basic graph of cosine. These are the 2 things I really need you to know for today. Now I'm going to stretch you with just one more thing, and that is, what if we had one that was like y equals 3 sine of 2 x minus pi plus, end parenthesis there, plus 3. That means this is vertically stretched factor of 3, and it's moved up 3. This is its horizontal, but remember, these are opposite of what you would think. You don't multiply everything by 2, you multiply everything by a half horizontally. All right, so these have names. This is called the amplitude. So it's whatever number's right there. This is just the B term, also known as the horizontal stretch or shrink. That's called, it's a shift, but it's special. It's called a phase shift in this unit. And this is vertical because it's on the outside. I've told my kids high, horizontal inside, and low, vertical on the outside. This one is the vertical shift, but it's also the midline. What does that mean? That means if we're going to graph sine, normally sine goes like this. And there's a line that runs right down here, right? What if I do this plus 3? Then I'm going to move the whole thing up 3. That midline moves up 3. And then my graph of sine just moves right there with it. The whole thing moves up 3. Okay? All right, there's the basics. And I'm only assigning you a few problems off of the worksheet. I'm not going to get to the complicated ones because I think that's too much for today. So on your worksheet here, I'm just going to have you do 1, 2, and 4. But on number 3, even though I don't need you to graph it, I need you to name its amplitude, what its period is. Hint, its period is 2 pi over b. So I'm going to teach you more about that next time. If it has a shift, tell what it is. All right, but just do that for number 3. It's a little too hard for you to graph right now, but you should be able to do 1 and 2 and 4. All right, that's your only homework for tonight. Have a great day.